Question says evaluate the sodic expression. Okay, so we have two given set of equation involving sod. Okay, we have 4 root 2 into 3 root 2 minus root 18 over 3. We have 5 root 2 over 4 minus 3 over root 2. So how do we evaluate this solution? So for 4, okay, root 2, that's number 1, into 3 root 2, okay, minus root 18 over 3, okay. So what do we do? So we can have this in root 2, okay. So how do we express it as root 2? We have root 18. So we look for the 2 factors of 18 in such a way we can easily find the square root of 1. Okay, so this 9 times 2 gives 18. Okay, so for the square root of 9, we have it to be 3 root 2. So we can easily replace this with 3 root 2. Okay, so here we have this as 4 over root 2 into 3 over root 2, which is this, minus, so let us replace this with this. So we have 3 root 2 over 3, okay. So when we look at the brackets, we can simplify further. So we have 4 over root 2, okay, 3 over root 2, minus, so 3 can cancel 3, so we have root 2, okay. So from here, we can work with the brackets by looking for the LCM. So when we do that, we have root 2, okay. So here is 1, multiplied by 3, we have to be 3 minus, when we divide this with this, we have root 2, so multiplied by this, we have root 2 square, okay. So we are multiplying everything by 4 over root 2, okay. So let us simplify what we have in the bracket further. So here we have this as 4 over root 2, okay, into 3 minus square root 2 squared, okay, over root 2, okay. So we simplify this further, we have this as 4 over root 2 into, so for 3 minus, so for root 2 square is 2, okay. How do we get that? So 2, we cancel this, okay, which is half, so we have 2 over root 2, okay. So here we have this as 4 over root 2 into, for 3 minus 2 is 1 over root 2, okay. So we can multiply the bracket, that we have 4 over root 2 times 1 over root 2. So here we have this as 4 times 1 is 4, okay. Root 2 times root 2, the same sort, we take out 1. So for 4 divided 2, we have it as 2. So for the second one, we have this as root 2, okay. We have this as 5 root 2 over 4 minus 3 over root 2. Okay, so when we look at this, we have 4 as the denominator, we have root 2 as the denominator. So let's make these two denominators to be equal. So we have to work with 3 over root 2, okay, and make 4, and make this to be 4 as denominator. So how do we do that? So for 3, okay, over root 2, so when we rationalize this, we have this as root 2 over root 2. So by multiplying both the numerator and denominator, so we have this as 3 root 2 over 2 times 2 is 4, okay, sorry. So we take out 1, which is 2. So for root 2 times root 2 is 2, okay. So we can easily look for the equivalent fraction of this, okay, of 3 root 2 over 2, since we are trying to have the same denominator. So the equivalent fraction of this, we can multiply both the numerator and denominator by 2. So when we say 3 root 2 over 2 times 2, so this one is equivalent to 6 root 2 over 4, okay. So we multiply what we have, the numerator and denominator by 2, we have this. So let us replace 3 over root 2 by 6 root 2 over 4. So from here we have this as 5, okay, root 2 over 4, okay, minus, so for 3 over root 2, let's have it as 6 root 2 over 4, okay, so we have common denominator, so let's pick out 1, so let's subtract the numerator, we have 5 root 2 minus 6 root 2, okay, so when we do this, so we have 5 minus 6, since we have the same root, so we can subtract, so we have minus root 2 over 4, okay, so another way we can do this is by taking this straight, so let's try this method, so let's take the least common denominator as 4 root 2, okay, so when we divide this we have root 2, let's multiply this with this, we have 5 root 2 times root 2, okay, minus, so let's multiply this with this, we have 4 times 3, okay, so here we have this as 5, okay, 5 times the same root, that gives us 2, so we have 5 times 2, minus 4 times 3 is 12, divide 4 root 2, okay, so here we have this as this, 4 root 2, so let us bring back this, let's bring it back to here, so for 5 times 2 is 10, minus 12, okay, over 4 root 2, so here we have 10 minus 12 to be minus 2 over 4 root 2, okay, so let's rationalize to eliminate this, we have times root 2 over root 2, okay, so here we have this as minus 2 root 2 over, okay, 4 times 2, since we are multiplying the same roots, okay, so we have this as minus 2 root 2 over 4 times 2 is 8, okay, so we can simplify, so we have minus root 2, when this divide this, we have minus root 2 over 4, okay, which is something as this. So either of this method we can use to get the result of this. The question says simplify and rationalize the sodic expression. So how do we do this solution? So for the first one, we have this as 4 divide root 5 plus 1, okay. So to do this, what do? When we look at the denominator, we have a root, okay, so we have to eliminate this, okay, and how do we do that? We have to look for the conjugate of this, okay, what do we mean by conjugate? So when we have expression like this with A plus B, okay, the conjugate of this means it should turn this to minus, okay, that gives us A with A minus B, okay, so we apply the conjugate of this by multiplying both the numerator and the denominator by the conjugate, okay, so let us rationalize. So when we do this, so we have 4 over root 5 plus 1, okay, so let's rationalize times the conjugate of this, which is root 5 plus 1 will now be root 5 minus 1 over root 5 minus 1, okay, so here we multiply this with this, we multiply this with this, so for 4 we have that's 4 times root 5 minus 1, okay, divide, here we have this as root 5 plus 1, okay, multiplying root 5 minus 1, okay, so for 4 multiplying this, we have this as 4 root 5, okay, minus 1, divide, okay, when we expand this, we have this as 5 minus 1, okay, so how do we get that? So for root 5, multiplying root 5, that is 5, okay, for root 5, multiplying minus 1, we have as minus root 5, okay, for plus 1, multiplying this, we have this as plus root 5, okay, when you multiply this with this, we have this as this, so we have this as 5, this is ours, this is 0, 5 minus 1, okay, we arrive to 5 minus 1, so here we have this as 4, okay, root 5 minus 1 divide, for 5 minus 1 is 4, okay? So we can easily simplify. 4 here is 1, 4 here is 1. So what do we have left? We have root 5 minus 1 as our result, okay? For the first one. And for the second one, we have 3 divide 2 minus root 7, okay? So we rationalize both the numerator and denominator with the conjugate of this, okay, which is the opposite of this. So we have 3 divide 2 minus root 7, okay, times 2 plus root 7, okay. So here we have root 7 over 2 plus root 7, okay. So here we open up, so we have this as 3 times 2 plus root 7, okay. So when we multiply this, we have this as 2 minus root 7, okay, times 2 plus root 7, okay. So here we have this as 3, the numerator, okay. We have this as 2 plus root 7, okay. So when we open up this, we have this as, for 2 times 2 is 4, okay. Okay, for 2 times 2 is 4. For 2 times this is 2 root 7. This 2 is out, okay. For root 7 times this is 7. So that's 4 minus 7, okay. The way we expand this, so here we have this as 3 into 2 plus root 7 divide, for 4 minus 7 is minus 3, okay. So when this simplify this, we have this as minus 1, okay, into 2 plus root 7, okay. So our final answer is minus 2 minus root 7. The question says we should simplify this expression. So we have a given set of expression. So how do we do this? Solution. So for 1 divide 2 root 2, okay, plus 1 divide 2 root 2, okay. So what do we do? There's a common denominator of 2 root 2, so let's use the LCM approach. So let's pick out 1. So we have 2 root 2, since they are common. So what do we do to the numerator? We add it up, so we have 1 plus 1, okay. So here we have this as 2 over 2 root 2, okay. So we can simplify this further. So here we have 2 here is 1 over here is root 2. These are simplified this. So for 1 over root 2, we can rationalize, okay, to eliminate these roots. So we have root 2 over root 2, okay. So what do we do from here? We multiply. 1 times root 2 is root 2 over, so multiplying the same roots, we pick out 1. So we have root 2 over 2 as a result of this. So for number 2, we have this as 6 over 2 root 3, okay. To eliminate this, we multiply both the numerator and denominator with root 3, okay. So when we do that, we have 6 times root 3, we have 6 root 3, divide. So here we have this as 2 root 3 multiplying this, so we have 2 times, so for root 3 times root 3, we pick out 1, that is 3, okay. So here we have this as 6 root 3 over 2 times 3 is 6, okay. So this can simplify this, so we have root 3, okay. So for the third one, we have 1 over root 2, okay. So we rationalize, so we have root 2 over root 2, okay. So here we have this as 1 times root 2 is root 2, okay. Multiplying the same roots, we take out 1 as 2, so our final answer is root 2 over 2. The question says evaluate this sodic expression. So we have the first one as root 12 over 2 plus root 27 over 3. The second one as in the parentheses, we have it as 3 over root 12 root 2 minus 1 over root 2, everything squared. How do we do this? Solution. Okay, so for root 12, okay, over 2 plus root 27 over 3, okay? So let us see the first way we can approach this, since we are adding, okay, with different denominators, okay, and we have root 12, we have root 27. So for root 12, we can have root 12 as, okay, we look for factors of 12, we can multiply together. We have 2 times 6, okay. We have 4 times 3, that is 12, okay. So we have 1 times 12 is 12 as well. So when we look at this, the square root of 4 is 2. So we have this as 2 root 3, okay. So we can represent 12 as 2 root 3, okay. And for 27, when we look for the factors of 27, we have 3 times 9 is 27, okay. So we can easily look for the square root of 9, okay. So for the square root of 9 is 3, so we have 3 root 3, okay. So here we have root 12, okay. So let's have it as 2 root 3, okay, over 2, which is this, plus, so for root 27, we can have it as this. So we have it as 3 root 3 over 3, okay. So now we can look for the LCM, which is 6, okay. So for the LCM to be 6, 26 is 3, multiply this with this, we have this as 6 root 3 plus, so here, this will multiply this, we have this as 6 root 3, okay. So when we do that, we cannot add up, okay, since we have the same roots, so we can add it up. For 6 plus 6 is 12 root 3 over 6, okay. So when we simplify this, we have this as 2 root 3, okay. So for the second one, we have this as 3 root 2, okay, minus 1 over root 2 square. So how do we do this? So let us evaluate what we have in the bracket first. So we have common denominators as root 2, so we can pick out 1, root 2, okay. So we divide this, we have 1, multiply by 3, we have to be 3, minus, when we divide this with this, we have 1, multiply by this, we have 1, okay. Everything squared. So here we have 3 minus 1 is 2 over root 2, okay, squared, okay. So within the bracket, let us rationalize this to eliminate this denominator, this roots. So we have 2 root 2 times root 2 over root 2, okay, everything squared, okay. So for 2 times this is 2 root 2, okay, divide, okay, multiplying the same roots, we pick out 1, okay. So everything squared. So here we can easily simplify this, okay. So we have root 2 square. So this implies 2 raised to power half, which is same as this root, okay, squared, okay. I can easily cancel it out straight from here. So when I do that, when I multiply this with this, I have 1. So I have 2 raised to power 1, which is same as 2. The question says, simplify this sodic expression. How do we do this? Solution. Okay, so for 1 over root 2 plus 1 over root 2, okay, divide 2. So let's work with the bracket. So we have common denominators and we are adding, so we have to pick out 1. So we have root 2, okay. So when we do this, we add up the numerators. We have 1 plus 1, okay, divide 2. So for 1 plus 1 is 2 root 2, okay. So we are dividing all this by 2. So what do we do from here? So let us rationalize this. So for us to rationalize 2 over root 2, we have to eliminate this root. And how do we do that? We multiply by root 2. We multiply by root 2, both the numerator and denominator. So when we do that, we say 2 times root 2, that is 2 root 2, okay. Multiplying the same roots, we pick out 1, okay. So we can simplify. So when we simplify, we have this as root 2, which is the result of this, okay. So we are dividing our results by 2, okay. So doing that, it's like saying root 2 okay, times 1 over 2, okay. So when we do that, we have this as root 2 over 2. Another method we can use to evaluate this, okay, is by distributing what we have here with this. So we have this as solution. So for 3 root 3, okay, times 2 over root 3 minus root 12 over 6, okay. So using this to distribute this, we have 3 over root 3 times 2 over root 3, okay, minus, so this we multiply this as well. We have this 3 over root 3 times root 12 over 6, okay. So when we look at this, let us multiply. We have 3 times 2 over, okay, root 3 times root 3, okay, minus, we have this as 3 times 12, okay, 3 times root 12, which is this, over, here we have this as root 3 times 6, okay, this is a minus. So let us evaluate this. So we have 3 times 2 is 6, multiplying the same surd, so we pick out 1, okay, minus, here we have this as 3 root 12 over, okay, 6 root 3, okay. So when we simplify this, we have this as 2 minus, so let us work with what we have at the numerator. So for root 12, okay, it's said as saying 2 root 3, okay, square of 2 is 4, 4 times 3 is 12, okay. So when we replace this with this, we have this as 2 root 3 over 6 root 3, okay. So do not forget, for 12 to be 2 root 3, we are multiplying it with this 3, okay, that we have here. So we can simplify. 3 here is 1, 3 here is 2, okay, 2 here is 1, 2 here is 1. So what we have left here, we have root 3, we have root 3. This can go as well. So everything has turned to 1. So when we say 2 minus 1, we have it to be 1. So let us refer this to as method, okay, method 2. The question says, without using calculator or mathematical tables, evaluate this expression. So we have 3 over root 3 into 2 over root 3 minus root 12 over 6, okay, sorry. So how do we evaluate this solution? So we have 3 over root 3, okay, multiplying 2 over root 3, okay, minus root 12 over 6, okay. So when we have the bracket, let us solve the brackets, okay. So here we have this as 2 over root 3 minus root 12 over 6, okay. So let's use the LCM approach. So for root 3 and 6, that is the LCM, okay, which is this. So when we divide this with this, we have 6, we can cross multiply. So for 6 times 2 is 12, okay. For root 3, okay, times root 12, okay. So when we look at root 12, we can have the same surd as 3. So how do we express root 12? So we can have it as 4 times 3, where we can easily look for the square of the first one. So that is 2 root 3, okay. This gives us 2 root 3. The square root of 4 is 2, okay. So let's replace this with 2 root 3. So we have this as 12 minus was 3 times 12, okay, we replace with this, which is 2 root 3, okay, over 6 root 3. So this gives us 12 minus, multiplying the same roots, we have it to be 1, so root 3 times root 3 give us 3, so we have root a times root a. Since it's the same surd we are multiplying, so we pick out 1. So when we say root 3 times root 3, we have it to be 3. From 3 times 2, we have this to be 6, okay, over 6 root 3. So let us replace everything with half here with this, but we can still evaluate further. For 12 minus 6 is 6 root 3, okay, so when we simplify this, we can have this as 1 over root 3, okay. So we have replaced everything here with 1 over root 3. So let's add it back, okay. Times, here we have this as 3 root 3, okay. So we have this as 3 times 1 root 3 times root 3, okay. So this gives us 3 over, multiplying the same surd, we pick out 1, okay, which is 3. So we simplify this, we have this as 1.